Hi, we're going to look at matrices and use it to solve simultaneous equations. The equations we have is 3x plus 2y equal to 4, 4x plus 3y is equal to 5, and we're going to use matrices to solve for x and y. First thing we're going to do is we're going to transform this into matrix form. We've taken the coefficients 3, 2, 4, 3 and placed it in a 2 by 2 matrix. We've taken the variables x, y, which is repeated, and we placed it in another matrix. And we've taken the right hand side of the equations 4, 5 and placed it in another 2 by 1 matrix. If we actually go and perform matrix multiplication on this, we will end up with the original 3x plus 2y equal to 4 and 4x plus 3y equal to 5. We're going to return to last week's lesson, which was on finding the inverse matrix. So we're going to quickly revise this before we go on to solving simultaneous equations. If we look at the matrix 3, 0, 4, 2, how do we find the inverse to this matrix? Firstly, we're going to interchange the numbers in the leading diagonal. Now 3, 2 is my leading diagonal. We can also call this the down diagonal, because if we look at gradient, reading a gradient, a straight line, this would be our down diagonal and this will be our up diagonal. And that's dealing with gradients, because from left to right the down diagonal decreases and the up diagonal in terms of gradient increases. So if we implement that, we would have 3, 2 changing positions to 2, 3. Secondly, we're going to change the sign of the other diagonal, and if we do that, we have 0, 4 which changes to 0, minus 4. Thirdly, we're going to find the determinant of the original matrix and divide the new matrix by the determinant. Now there's 3 steps involved in finding the determinant. Step 1, we multiply the numbers in the leading diagonal, which is 2 and 3. So we have 2 times 3, that gives us 6. Secondly, we multiply the numbers in the other diagonal, which is minus 4 times 0, and that will give us 0. Thirdly, we take the product of the down diagonal, which is 6, and subtract the product of the up diagonal, which is 0. Implementing that, we have a determinant which is equal to 6 minus 0, giving us 6. Now remember, the point said that we need to take the determinant and divide this by the new matrix, which we have 2, 0, minus 4, 3. If we're dividing by 6, we're actually multiplying by the inverse of 6, which is 1 over 6. If we implement that, we have the determinant 6 multiplying by its inverse, 1 over 6. And we're taking that and multiplying it by the new matrix 2, 0, minus 4, 3. We will now perform scalar multiplication. 1 over 6 times 2, and that will give us 1/3. 1 over 6 times 0, which is 0. 1 over 6 times minus 4, minus 2/3. And 1 over 6 times 3 is half. You can check this out with your calculator. If we take our original matrix and multiply by the inverse of the matrix, we would end up with the identity matrix for a 2 by 2. And if you quickly perform the multiplication on the two matrices, we have the original multiplied by its inverse, row 1 multiplied by column 1, and then we take row 1 multiplied by column 2, and if you do that, you will end up with the identity matrix, which is 1, 0, 0, 1. And we know if we take our original matrix and we multiply by the identity matrix, which is 1, we would end up with the same matrix. So we're going to apply this to our simultaneous equations. Rewriting in matrix form, which we spoke about, 3 minus 5, 2, 4 goes into our first matrix. Then we have our variables, and we have the right hand side in the last matrix 12, 7. The first thing we're going to do, we're going to find the inverse of the 2 by 2 matrix. Now remember from the previous slide, for us to be able to do that, we need to interchange 3 and 4, which gives us 4, 3, and we change the signs of the up diagonal, which is minus 5 changes to 5 and 2 changes to minus 2. We now need to find the determinant, and to find the determinant we're going to take 4 times 3, we've got to look at the original, 3 times 4 is 12, subtract 5 times minus 2, which is 10, and minus 10 gives us a plus 10. So we have our determinant, which is 12 plus 10 giving us 22. So we're going to multiply this new matrix by 1 over 22, and that is our inverse matrix of 3 minus 5, 2, 4. If we take the original matrix and multiply by this inverse, we will end up with 1. So we're going to take the inverse and multiply both sides of the equation by the inverse matrix. Implementing that, remember what I said, if we take this matrix that we have here, the 2 by 2, and multiply it by the inverse, we will end up with the identity matrix, which is 1. So we don't need to show that. And then we have xy, so we have 12 over 7 multiplied by the inverse. Just to recap what we are doing, we are multiplying both the sides, left hand side and right hand side, by the inverse matrix. So if we do that, we're going to take the two matrices. Let's first perform matrix multiplication on the two matrices. And if we do that, we're going to get row 1, column 1, 4 times 12 is 48, plus 5 times 7 is 35, giving you a total of 83. Then we're going to take row 2 multiplied by column 1, minus 2 times 12 is minus 24, 3 times 7 is 21, minus 24 plus 21 will give me my minus 3. Now I have my 1 over 22. I'm going to perform scalar multiplication. 1 over 22 times 83, which will give me 83 over 22. And 1 over 22 times minus 3, if you missed that, I've showed that here. 1 over 22 times 83 is 83 over 22. And 1 over 22 times minus 3 is minus 3 over 22. And so we have xy is equal to 83 over 22 and minus 3 over 22. Split them up. We have x is equal to 83 over 22 and y is equal to minus 3 over 22. Thank you.